the reason why we are here and the reason why we are interested in research is because lots of our colleagues have PhDs, have postdocs, and we are always excited to do more of that. We have completed more than 100 research projects. I think we do have 13 active research projects right now, and we're proud of like 20 plus TWT alumni are currently professors around Europe. This project is on quantum computing. I was asked to present that mainly for Frank Lyman from Mr. Kickeisen, since he wasn't able to join. So just a very brief overview. It's about quantum artificial intelligence for the automotive industry. So the partners that we have here are Mercedes, E.ON, DFKI, and Rechenzentrum Jülich. The goal of this project is to build a comparative performance evaluation of the potential quantum advantage of quantum machine learning, and our contribution from TWT is on quantum-assisted AI surrogate models for chassis design and one more for route optimization. What I mentioned before, I'm part of the research department at TWT, so this is like an overview of the research that research domains that we are actively writing proposals. My focus is on the energy and sustainability, but my other colleagues focus on the rest of them. And as I mentioned before, we do lots of research that are the main venues and where we apply our proposals. We are also proud that we win some awards while doing this research, and yeah, that's just like to give you an overview and show off a little bit. This is also how we usually partner with universities. And we have a strong academic network with more than 200 academic partners through more than 50 institutions. We write research proposals with them. We actively work on research proposals. We do also have master theses and write papers together with professors and labs, and also participate on lectures and laboratories. I'm just going to go very quickly over that. We write papers, there's just like the proof of it. We do also write papers with our customers when we are able to motivate them. This is our company, which is located in Johann, as I've said. I'm just going to skip that. And this gives you kind of like an overview of our research activities currently. So like in the light blue, are active research proposals in the different domains, and with this turquoise color are TWT products that are associated with these domains that we are actively working on. Lots of them are associated with AI and LLMs, and this is also the reason that motivates also the next part of the talk. So the green code is a research proposal that I'm actively participating in. It's a large consortium funded by the different countries. It's we are more than 20 partners. Here you can see the German consortium, and I'm going to show a few of the findings that we have so far. So I wanted to give you like an overview of green code, right, and green ICT, which is like the broader concept of encompassing various disciplines aiming to reduce the environmental impact of technology. And this goes from hardware, sustainable data centers, but also the computing part. And the green code specifically refers to the practice of writing code in a way that minimizes its environmental impact. And when you think about that, this has like two aspects. The one which is like the code that I write is efficient enough, and then the other part, which is associated also with the green AI, is writing it with the right LLMs in order to reduce also the inference cost that is associated to that. our main focus areas of this. I have like a second slide which I might just like say a few more words about that. So the code measurement pipeline, I presented that last year, where we were looking into the coefficients that the coefficients and the parameters that contribute to the green code. We have published also 2 papers so far in that direction. Currently, I'm mainly working on the LLM inference cost, which is also like the focus of our team. And the data centers are in collaboration with Harvard. I'm going to show a few details on that. And the future of green ICT in Europe, I'm collaborating with a team of Professor Marco Aiello on that. And this has been a study, a Dutch study, that we want to scale into a European study, and we want to understand what the future of green ICT is going to be in the future. We are interviewing stakeholders in the field, and it's very interesting. I've seen so far the German results, but I'm excited to see how this is gonna evolve. So I'm just gonna, I said that I shared a few results about what we did on the measuring of code's environmental impact, but just to give you an overview and maybe to build some awareness and to make you try it out. So these are like multiple tools that you can use right now to measure the code that you're developing. So one of them that we are using is Perf, Rubble, and Green Code, but there are multiple tools out there that you could like try out and to see like during your pipelines and while coding to see, okay, how much emissions does my code emit. But we moved on from this part, and like where we see like the gap is between the existing software measurement tools and like a general reporting of like how much emissions are associated to code. So everyone, or almost everyone, is using LLMs currently to write code. So our platform and like what we're trying to build here is an AI assisted end-to-end platform that enables, develops, and measures the code, both the LLM and the code, and both the LLM inference, but also the developed code. So I'm gonna share a little bit more about that. So as you can see here, that's like the vision. Here, the way you can understand is like you input like either a request or an existing code, then you refine it with LLMs, and then you measure the environmental impact of the generated code. And we measure both aspects, the LLM inference cost and the code. And one other thing that I'm going to show in a bit is that we want to understand also like the whole environmental aspect that is associated with the code development, and that's why we're looking into the lifecycle assessment. Lifecycle assessment is a methodology that has been applied in multiple product development, and there you want to understand what the environmental impact of each stage of product development, like what the environmental impact of each stage of the development is, and like why we're doing the LCA is that we've seen that the cost, the environmental cost, is in like various aspects of code development. It can be on the laptop of someone's, it's on the servers, and it's also like sometimes just on the cloud, and it's very hard for the teams and like for the software developer to have any visibility into like what the environmental cost is. So our goal is to produce a single global warming potential score for real software products. We know that this is not going to be accurate, but we at least want to get like a rough estimate of like what this is, and mainly because we are using a lot of LLMs lately. We're using them every day, all day, and we just want to understand better the environmental impact. Okay, so this is just like a picture of like how we have defined the LCA of software development. Here you can see the different stages. So for the product stage, it's, for instance, the hardware infrastructure. For the data centers, the development stage is like while you're using cloud code and develop the code, and the use stage is like where you use probably perf or code carbon to the code. And the end of life, which is like very often neglected, there we don't have so much information yet. This is kind of like the pipeline that we use for the LCA. The one and most important aspect, I'm gonna say, is like this LCI, which is like an inventory of the life cycle. And this is about, for each of these stages, building an association to the environmental impact of that. To that, we're not there yet. We're collaborating with the other partners of the consortium to try to build an LCI that is acceptable. I'm gonna put it this way right now, but throughout this research, we found that this is kind of like the hardest challenge. If any of you have any ideas, we're like more than welcome to hear them. And as I've said, the LCI is not accurate right now, but like this is an example output how the LCI could give us and like show how the contributions of like the different stages are. And to do the LCA, we're currently using the OpenLCA open source tool. We are modifying and completing it with some other aspects that are necessary, because like this is mainly used for other product types, and I think like for now we're like pretty happy with that. Okay, I'm gonna move to the measuring vibe code's environmental impact. And as I've already pointed out at the beginning, inference and not training is the long-term energy cost driver. As AI integrates into daily workflows, coding agents, chatbots, the cumulative cost of billions of requests skyrockets. And this has motivated us a lot into understanding the environmental cost. But to be honest, I think like the one part is the environmental cost, but at some point it's going to be like the cost itself as well. So it's very highly correlated. So what we're trying to do here is to see and compare the large language models and the small language models, and to build a CO2-aware integration of large language models into vibe coding pipelines. So our demonstrator that I showed before wants to be able to select the right model in order to the right model to develop the code in regards to the environmental cost. So inference cost is very important for us. There has been work on the data center's inference cost, but where we are focusing is on-premise hardware. So I assume most of you have bought GPUs and are interested in like knowing and understanding what the LLM inference cost is part of that. I'm going to show in a bit like what we're doing here. So on there could be like three ways of like doing it right now. The one is, okay, someone could say, okay, I'm just going to go to the hardware and directly measure the energy cost. This is not always possible. If someone can do that, it's great, although it also just gives you like an overall cost, and you cannot like eliminate the specific request that you're doing. So what we are doing here, this is also like a paper that we just submitted, it's still under evaluation, is a semi-analytical estimation where we are combining open parameter models with specific hardware, and also like other parameters such as the prompt length, in order to understand and to measure and to give values of like how much the inference cost is for each of the input and output tokens, because like that's also like an important distinction. One of the parameters that we consider in our methodology is the length of the prompt. So as you can see here, a very long prompt, which is like more than a 10K prompt, is almost 3 times more energy heavy than a short prompt that is like less than 2,000 tokens. So that's something that we need to take into account. And just like a short overview of some of the findings. While comparing Qwen to the open parameter GPT from OpenAI, we can see like for the same request, we had a 70 times difference in the millijoules here. And what we haven't done, it's like part of the future research, we want to understand also the quality of the output, but right now we're like mainly looking into the energy part. Okay, and I'm just gonna move to the last part of the presentation, which is about understanding data centers' environmental impact. The lab that I'm collaborating with, they are working on data centers, understanding the environmental impact and the health impact that they have on local communities, both from the electricity and CO2 emissions, but also like from the water scarcity. One simple question that we asked and we were interested in finding out is whether the 100% clean energy claims that the big tech make are actually reproducible, and whether we can like really find out that they're using just green energy. And what we figured out, our study reveals that a structural gap between the financial sustainability accounting and the physical grid physics do not match. I'm going to show a few of our results here, but if someone wants to discuss that further, I'm happy to discuss that afterwards. So just like to understand why our motivation is here, so in 2024, 16 terawatt was used for the computational and AI workloads from 2014 to 2016, and this increased almost 3 times, taking up to the 4.4 US electricity by 2023. And there's like a few projections about 2028, and this just skyrockets even more. There are also other, I would say, aspects that are very important, like the spatially concentrated scale and the temporary inflexibility. I'm not going to go into details right now, but the way you have to think about it is that data centers in the US are built on specific areas and specific states because it's regulated like that. It's not how the permits are being provided, it's not based like on the environmental aspect, it's only based on like where the states are like more data center friendly. And here it's kind of like the explanation of this narrative and how this is actually being done. So the companies are completely illegal. I'm not saying that like any of their claims are illegal, but the way it works is that on the yearly average of the electricity consumptions that they have, they actually buy electricity credits, the RECs, and instead of like matching the hourly electricity consumption that they have, they are being able to purchase agreements that like helps them doing the balance of the electricity consumption. So like, just to give you a simple example, so if the grid is producing or using just solar energy at 2 p.m., then the data center obviously can use this green energy, but at 8 p.m. if fossil fuel is the main energy source, then the operational reality is that the data center is also going to use like fossil fuel, even though all over Google and all over their sustainability reports, you will see we're using 100% of green energy. That's it from our side. So like, if anyone has any questions, like feel free to ask them now, or if you want to connect with us, that's the team. Patrick and Michael, they're like more on the data product. So thank you so much.
Thank you very much. Other questions? Marco.
So, you tell us about
the measurements and then also the data centers, but what can we do? Right? So this is how we can account for it, which is report.
Yeah.
And then we're measuring. And the flexibility of the AI loads hurts. Is it really so? It's not flexible?
To be honest, like I'm gonna start with like the first part of the question. So, like what I figured out while working on this domain is that the first thing that we have to do is that we have to find a way to measure things, and we have to start measuring things, because like I assume nobody, like also in this team, is really thinking when they're like writing this new AI algorithm, for instance, they never check the environmental cost of it, right? So this is like where this whole discipline has to start, like bringing that concept into consideration while we develop new things. And I think as soon as we start having enough data and enough information about like how much it costs, and like then we will be able to make improvements. So right now what we are doing, like with just like the few results that we have, like using the appropriate LLM or SML to write the code is something that, I mean, we don't need to do right now. Like nobody forces us to do that. And like that was also the discussion with the stakeholders that we had from the Green ICT study. So right now, like also like one of the interviewees said, like there's no incentive right now for people to do any of this work. So regarding the AI load, there are I'm not the specialist right there, but I think that there are a few solutions in regard of like maybe storing some energy, or even like building other than solar energy solutions, wind energy and so on. But to be honest, this is like the extremely optimistic perspective, because the reality is right now they're building data centers that are off-grid, that are not connected to the grid, and they're gas or nuclear is, they're trying that, it's not there yet, but most of them are gas operated and not connected to the grid, so they can just produce as much energy as they want. So the reality is kind of scary.
Thank you very much for your interesting talk about the environmental cost of using LLMs for byte coding. I'm not an expert on this, but the question arises in my mind. It is about, there is some study comparing the environmental cost of using the same persons, persons to produce the same code, using byte code. I mean, when we say, okay, this is very costly, environmentally talking, what we are really meaning, in fact, is that it is more costly than doing it with persons. Is correct? So is there some study that gives us information about how is the environmental cost of producing the same code using persons?
Yeah, so on the previous study that we did, we weren't able to quantify so well the humans' environmental costs. Like maybe we could, it would be just like how many hours you worked on that and just measuring like having your code open or something. What we did is that we compared, like it was for a software testing example, and we compared the cost writing this code compared to the cost running it. And on testing software, you run it usually once, right? And the surprising thing, it was like the inference part, like developing this code, it was 9 times higher than the actual code running once. And for codes that you run like multiple times, it's like nothing. But if you always have this overhead of like plus 9x% of energy, it's significant, right? So, but I don't think like that the human code for 8 hours would be comparable.
You also have to have into account how much is the cost of having a person developing. There is a long learning process, long learning of lead, so consuming, so having environmental cost. So
Yeah. And to address that, I feel like we don't want to stop people writing code with LLMs. We are big fans of it. I am a big fan of it. We just want to make it in a way that it's a little bit more sustainable and like trying to integrate this and thought into this methodology and pipeline.
thank you.
Thank you. Last question.
Thank you for your presentation. And I'm kind of interested in that. And I know there are some experiments made by the Microsoft that they have built up the underwater, that they put their data sets into the water, so that they said they will minimize the cost of the cooling system. But you know, cooling system also emission very much of the carbon structure or something. Do you think that might be a way of reducing the emissions and something influencing the environment? Or maybe, yeah.
To be honest, I haven't looked into that at all. I think that people that are skeptic about that, they say, okay, how you like the ocean could be impacted. There's a trend about building data centers in the space right now, so maybe that's also the new trend.
Okay.
Just be provocative. So if we need less time for developing with LLMs, which is very clear that it is, we could counter calculate the human impact. If I only need 5 people in the lab,
Speak louder a little bit. Yeah.
so if I only need 5 people instead of 10,
Yeah.
they eat less, they don't need housing, so I think if we do just calculations, I think that's fair enough to calculate. Did you see any of this? Because obviously it's only quite into these calculations. We talk about it, we have a lot of different papers. So is there sort of a holistic, because sometimes when you create the software, you solve problems that were done. If you look at each different software, it's 5% more. So you can spend a lot so I think the complex, at least if you look now at cost, it's much more complex than a lot of people say.
I mean, that's a fair assumption that less people are going to be working on it. I think like the main motivation on this work is not about like the global reduction of LLMs and like using them less. So this would go like more into that direction rather than what we currently have on like how we can improve it to make it better, right? So I think that's the difference, I would say. But I assume yes, like if we need less people, maybe we need to reduce also the amount of population. So it's a very open-ended problem, this. So I agree, it's very hard to address that. But yeah, thank you for the question.
Okay, thank you again. Yeah.
So Stanford University started a new company called Samanova, where it's as powerful as NVIDIA. In 1/4 of the power consumption, it's air-cooled, not water-cooled, and it's actually multi-system design.
Yeah.
So it's a competing architecture, and it's probably going to overtake at some point use it. So it's called Samanova.
Okay, perfect.
But it's Intel is putting a lot of money into it. It's highly efficient, highly sophisticated. We use it.
Perfect. Thank you
Okay.
for running this.
So thank you for. Now let's move to